thank you for coming out to the 7th libsurvive live stream. And, man, things are just cooking along. I was just really surprised by how much people have gotten together online and just the various things that we found out we've needed along the way. And really, this project has been so much bigger than I expected it to be. I figured we'd just get some, scan data, some lines, and just throw it into an algorithm, and we'd get, ooh, that's where the HMD and all the Watchmen are, and everything will just work. And the answer is, no, it's really actually very hard. I normally go into a room always assuming I'm the smartest person there, but really ready to admit that I'm not. And this is definitely one of those times where the problem of what this HTC Vive is doing is a lot bigger than I thought it was. So one of the things we ran into towards the end of the last live stream was a comment from Alan Yates, basically like, well, I guess that's the best he's going to be able to do before he gets the OOTX Cal data. And I'm like, really? Is it really that important? And the answer is, yeah, it really is that important. So I had my friend Josh here.
Hello.
He was my roommate in college for many years. We actually worked on a game engine together for several years too. And I was like, he's like, hey, can I help out at all? And the answer is like, yes, you can decode some OOTX data. So the OOTX data, for those of you guys who don't know what it is the data that comes from the lighthouses, because there's no mechanism easily for the lighthouses to send data to anything else except for through the light coming out of the lighthouses and the sync pulses. The sync pulses aren't just a sync.
We should find that.
And then
that GIF or
a
video
flash. Can you find
flash,
it?
Yeah.
Find the video and we'll pull it up. At any rate, point is, it's a fairly complicated protocol, dealing with a lot of wacky bit stuffing stuff, just like the crazy Ben coding on the Watchmen. And Josh was able to kind of take that and turn it into something actionable. Is that the...
I don't know.
Yeah, I think if you just do view image or whatever, it would probably be fine. So he's still pulling that up. So, let's see here. Sorry about all the streaming issues earlier, too. Anyway, so thanks for coming out, everybody. So we've gotten a number of things. People are coming up a little bit more recently than before. MW Attorney is really kind of putting in his 2 cents towards this project. Initially, we were going to do everything strictly with the headset and the Watchmen, but it's looking kind of important that we do something a little bit more generic. Just so you guys know, Josh just pulled up the image right here. This is what a base station looks like. This is an early version of the base station. And specifically, the OOTX data is what's encoded in these flashes, which are specifically coded lengths of time, in order to actually transmit the calibration information about the Watchmen. Actually,
it works 1 bit at a time. So each flash, you get 1 bit. And then it has to be basically stitched together to reveal the entire frame. Hey, Brendan.
Do you want to talk about it? Do you want to talk about it a little bit more? Just
Not
go
really.
into how you decoded it and.
Basically, the way that it works is the decoder constantly looks for the 18-bit preamble, 17 zeros followed by a 1, and once it picks up on that, it starts pushing the individual bits into a buffer, and once it reaches the transmitted length, it calls a callback and lets the library handle what it wants to do with the data.
There. Oh, no, if you leave that open for a minute, sorry, the people didn't see. So what was going on is it's this flash right here, and these are the 2 rotors, but it's this flash that happens, and that is a specifically coded length of time. Okay, and you can pull up whatever else you want now.
I was going to pull up the source, but I guess there's really no reason to.
Either way. Let's see, I'm going to set this to always visible workspace so I can see it over here. I guess that's good. Yeah, so that worked out fairly well. Okay, so some of the things that we've done since last time was that, and another big one was taking, for me at least, I don't know how big it is for other people, But, oops, let's pull open this one. For me, I was able to, let's calibrate. So right now what you guys are getting, make sure you can see that clearly. Is that visible there? It's kind of, let's bump this over here. Okay, and then this should probably be visible there.
It is a broken fan. My laptop sounds like an engine.
Let's see. I put this down here. Oh, sweet. This means I can actually monitor it while. Okay. So I'm going to just point this over there so you guys can see what's going on with it. So right over here, I have the main headset, and this is the normal display that we've been using for some time. This thing right here is just kind of as I move it around. It's both the X and Y view from each of the two lighthouses there and there, kind of overlaid on itself. Got there, and we have the Watchman as well. So, like this is a Watchman here as I move it around. Can you bend the camera up just a little?
Sure.
And so as I move this around, you can see it changing the data in real time, and that's great. So this has all kind of been the way it's been for a while now. Why this Watchman is not waking up. Sometimes when they're charging and you power it on, they get a little bit wacky. Remember, there's a big delay with that. Okay, whatever. That one will be fine soon. So what really happens here is we have survive cal.c. Ooh, let me fix that font so you guys can see it.
Charles, I closed the sliding glass door.
Thank you.
because the
Yeah.
is-
Yeah.
Do you want me to get this window too?
Yeah, that'd be good.
Okay.
Is the font good for you guys? Can you see everything clearly?
The Watchman has.
Like at 12 point, is that good? I'm going to assume that that's actually a little bit smaller, so that's... Okay, let's assume that that's good. So inside of Survive Cal, it contains a state machine which kind of iterates through all of the different states in which we would want to cal. So I'll walk you through what that looks like right now. So I can just run calibrate, enter, and power on the headset. And if I... Okay. So now I have Watchman 1 and Watchman 2. Let me restart that again so you see what happens when it first starts. So if you look at the very top of the screen, it says collecting OOTX data 00, and then those numbers count up. They're counting the byte number in which the OOTX is currently receiving for each of the base stations. So once it gets that, it knows it's good to go. The other thing I have is these Watchmen I can put down on the ground, and it's going to try to find a common point on the Watchman. Oops, that was a little bit quick. It's probably not going to work out, but we'll see. So at any rate, it's right now collecting sweep data internally. So this was something that was kind of done before in a very manual fashion, but now it's pretty much automatic. So it's collecting the data with the Watchman and the HMD on the ground and all of that. And then what it's going to do is it's going to go run the lighthouse find algorithm on the data, and it's a little bit rough. I think that's probably kind of wrong, but that's reasonable data for where the lighthouses are, and it stores that back in the data structure in libsurvive. So now libsurvive is actually able to do a room calibration inside of itself. It doesn't really do that much beyond
They want you
it.
to scale down the camera.
Okay. There we go. So that's really kind of like the new thing, is that now we can just inside of libsurvive itself, there is the mechanism for self-calibration. Now, this is probably going to change because, as I was mentioning, MW Turney wants to be able to use this with his own hardware instead of just specifically a two Watchmen and a main Vive. So we are going to have to change some of that. The other thing that I really wanted to talk about today was the pose estimation information. And so right now, the way that we actually do the camera finding, there's really two ways that we've been playing with it. One is the way I do it, and the other is the way that MW Turney does it. MW Turney does it using a series of tories, like torises, where it I don't know, it's kind of difficult to describe. Let me see if I can have see if I can pull that up here. By the way, if you're curious about hopping in and getting things going, the GitHub issues are a pretty good place to do it. Let's see here. So his solution for this had much more to do with finding the relative distances between points. So mine has much more to do with simulation of an environment and then moving a camera around in a whole bunch of places and trying to find the best possible location. His, on the other hand, has much more to do with, I think it's MW Turney, not Lee Cook. Maybe it could have been Lee Cook. I'm sorry, I get those two guys confused so frequently. No, it looks like MW Turney's. So for his, it produces a series of possible toruses of where the lighthouses could be, and goes from there. Mine is just a fundamentally different way where it simulates the lighthouse. I've forgotten its address. This one? Yeah, this is it. Oh my gosh, it's so smooth on this computer. And so what I do...
What is this?
What this shows is the probability of where the lighthouses could be. So if I do this, it shows me that the chances are that the lighthouse for the L lighthouse is probably somewhere in there, and the R lighthouse is somewhere over there. And yeah, that data's kind of rough, so I'm sure that there's going to be some more work done to kind of resolve that. But those are really two different approaches. I don't know, I thought it was just kind of interesting that would work that way. Now, what I really wanted to go into, though, was the discussion of what's really going on here with mine and why I think that it's kind of a fundamentally bad way of doing it. So what I'm effectively trying to do is I pretend that we have at the origin the HMD, that's the head mount display that's sitting right there on the floor, and I'm calling that my origin. And then what I do is I iterate through, and as you can see, this is just voxels, so it's a bunch of individual discrete like checks. And I say if the lighthouse was at this point right here, right there, would that work? Would that produce a is that visible? Can you pull it up on your screen and see if it's...
Well, I actually closed the screen and left the chat open.
Oh. Wait, does that work?
Yeah.
Oh.
If it's popped out.
So at any rate, what I do is I try it at every single possible location, and I say, well, okay, if we point the lighthouse at the origin with this particular set of properties and move it around and all of that, then, well, what is the probability that that's where the lighthouse could be? And I produce this graph of all of that. Now, that's the backwards way of thinking about it, it turns out. What I really wanted to do was to use that to solve where the lighthouses were, because we do need to know where the lighthouses were. But you can also use that to determine where the headset itself is. So both directions. And this, I think, goes back to a comment that Alan Yates made at the end of a live stream. I believe it was live stream number 3, when we had a single lighthouse pointed at a headset, and he's like, yeah, find out where the headset is. And I'm like, well, that seems useless. We should have 2 lighthouses and go from there. But really, if you can figure out where a given object is from one lighthouse's point of view and figure out where it is from the other lighthouse's point of view, you can go a long way to resolving where the actual object is. And I think that's the direction I want to head. I think I want to just scrap this solution and this mechanism for finding the lighthouses and instead write some code to just try to find the location of an object based on its angles, and then use that code in reverse to find the lighthouse, and then use the code normally once the lighthouse is found for everything else. So that's one change I want to make. I don't know. I don't really have anything else at the moment for the introduction, summary, or demonstration. Let's see, what are people chatting about right now? Yeah, libsurvive is supposed to run on really low-end systems. Goal is minimize dependencies, minimize requirements, and yes, potentially even run on the ESP. This visualization here of the probability cloud cannot be run in real time as it is, but that's mostly because there's no real data for it to be processing in real time. I think it would be a lot of fun to try to figure out some way of streaming data to a web page dynamically. That would be a lot of fun. But I don't have any data to do that with right now. So, not really sure what to go with from there. Some of the other things, I wanted to mention. So right now, all of libsurvive is relatively static. So if you look inside of surviveinternal.h, there is a structure for the survive context, which has a lot of basic stuff in it. I guess we can view us now, right? Yeah, there we go. In here, there's a lot of just functions and other stuff that have to do with really specifically headset and 2 watchmen data. Like here, we have the data structure that contains the headset and the watchman. And really, this should be switched out to be much more of a soup of various types. There's really no reason for it to be hard-coded in here. Out of sync, heard wrong button before tabbing to FB. What is that? Hello, are we out of sync? I guess I'll wait until we find out what people say. But yeah, Voxeltastic was not meant for dynamic data, but I think it could totally run with, my other favorite technology, WebSockets. So one of the things that we're going to need to do is be able to have driver registration, and this is going to be a similar technique from what we used on color cord. And what that allows you to do with something like color cord, let me go check that out. So what you can do is you can write code that would be a driver for a given device or potentially a calibration system. And then, instead of having to have like a bunch of complicated switch statements or anything else that would check a certain driver or not, you can simply register your driver. And that can just be done right here. And the really big benefit of this is you can simply link against libsurvive, and you'll be able to have your own driver built in. So you won't have to recompile libsurvive to add in custom new hardware or new fundamental ways of doing things in libsurvive. It'll just be able to be registered in with the driver. The other thing is that Survive is finally getting big enough now that we really need a preference system. So that's what I've assigned Josh primarily. Do you want me to go over there right now? Remember, they can't see the whole thing. It's
Yeah. I'm trying to resize this thing.
a little bit bigger. Whatever, it's fine. So do you want to talk about it, or?
Basically, the way it's going to work is it's going to read data out of a JSON formatted file. The reading's not done yet. I wrote the writing stuff the past hour or two, and I haven't tried it out yet, so it's probably going to crash. So that should be interesting when we get around to doing that. Not really much to talk about. It's boring, boilerplate configuration loading.
Yeah, but unfortunately, we're kind of at the point now where it needs a little bit more boring stuff to get things moving well. Yeah, I don't really know where to suggest from that. I don't know. This was, I guess it was intended to be a short live stream. I don't think it was intended to be this short of a live stream, though. But I have everything on my list checked off now. And I don't know. What do we
do?
Yeah, what do we do?
Charles, you think you can get a VR to work on this?
What is it?
It's an Amiga 1000.
What processor does it have?
68,000, 7.16 megahertz.
No.
What if I upgraded it to 28?
Maybe.
Okay, I'll work on that.
Is floating point involved? Does it have a floating point unit?
No. But I have a 68030 that runs at 25, and it has a 68881.
Does that have a floating point?
Yeah.
Okay, that'd be fun.
You want to try that?
Do you have a C compiler for it? Or
Yes.
do you have a
They have
modern?
C compilers. Yeah.
Okay.
Modern
I don't know if
Like
it's...
a modern development environment, so you can code it and test it in a reasonable length of time.
What is the oldest you would consider modern?
My question is, can I work on my desktop and say like, push it to that and test it?
Okay. Well, I mean, it could be on the network, so you could just work on it. But would GCC like 2 be okay?
I don't know.
Probably not.
Probably. I don't know. I don't see why it wouldn't. libsurvive is pretty benign.
I'm trying to figure out what you consider modern, because, like, obviously certain things are just not going to be supported, but...
Well, let's see. When was GCC2 created? Oh, can you... Sorry. Let me...
I'm going to get a trash bag so this doesn't get wet.
Okay.
Because it's going to
Let's just check that. I'm curious. Would I be able to do GCC2...
Why don't you search for, like, GNU Environment Amiga or something, because... I haven't done enough with...
Let's see. Compiler for Amiga OS M68K.
Oh, see, it stopped in 3. So you'd be able to do GCC 3, GCC 4, or, yeah, 2.95.
GCC4X does not support the M68K.
But 2.95 is...
2.95. I could probably get it to run in 2.95. So people are talking here. I want to know why all the young people use 4 space tabs. I don't use 4 space tabs.
I do.
How young is young? I use 2.
You'd better be making them tabs.
They are tabs. They're
Okay.
not spaces.
Yeah, well, then who cares
displays
how many
it.
spaces it is?
Is
Spaces.
this really tab delimiters versus space characters?
Oh, yeah. Well, don't worry. libsurvive is tabs only.
Okay. Yeah, I won't be working
We don't
on
use
it.
spaces.
Well, I know you won't be working on it because it's C, so...
Yeah.
Brendan likes Python and he hates JavaScript. That's, yeah, I don't get Brendan. Okay, I don't really know what else to test right now. I mean, we can fire up LibSurvive some more and play with some of the data.
What were you working on earlier?
Well, I mean, what I was working on earlier was getting the, oh, it's still running. Herp derp. Was getting it so that it would actually be able to find all the lighthouses and save in, the, Python is life, JS is love. Oh, you people are so weird.
Great COBOL.
That's a great pile of comments there.
Yes, it is. Linux 68K. Oh, boy. Yeah, get Linux running on the Amiga.
You can.
Although, that's another question. How would you get the Amiga to output to the HTC Vive's video? Scalar.
VGA to something converter?
Ooh, that would be a slow, like, frame rate. You know what? If you're
It's an
playing,
Amiga!
if you're playing the Vive on an Amiga, you're probably gonna expect to puke a couple times. That's fair.
Charles, may I borrow this power brick?
Yes.
Okay. I will bring it back.
Okay. I think my laptop had enough time to charge.
Oh, is it actually?
Yeah, it's yeah. No, LibSurvive is definitely gonna stay in C. We're not doing any of that other
Nonsense.
problems. Yeah. So data recorder. Let's see if that still runs. Yeah, it does. So I can still output this data. Actually, you know, one thing I really wanted to do was in here. What I want to try doing is I want to try making it so it'll output the IMU as well, because right now it's just not doing that. So let's see if can I just save it and run that?
If you want to just
Okay.
a plastic bag.
We had also earlier in the week talked about recording the live data so that we can play it back later on a simulated Vive, so that people who don't have Vives can continue developing.
Pressure washing stance, but
Okay, that seems like a reasonable thing for us to work on live.
that's not for me.
First of all, I think I do want to get the. Let's see, how would that work? We probably want to make it so you can stream,
Soaked.
because we have this right now streaming to the terminal, and then I wrote that tool last time, which tools, data server. So let me try tweaking this some so it's a little bit more robust.
I'm just gonna throw shoes on. I can just. If you can just leave the doors unlocked.
One thing I'd like to do, anybody who's up for it, I would like to try to run the data server again. If somebody on the internet can connect in and just try that out, I think that would be pretty cool.
Okay.
I had an idea as to what I think was causing the data to drop out pretty bad before. So let's see if I can.
Hey, don't don't ship VNC for a bit.
Okay.
Holy rain.
Yeah, it's been raining pretty hard here. Arseno Dev, did you say that it was hailing there, or what? What kind of weather were you were?
Probably just heavy enough rain.
No, he described something pretty crazy. Wait, recording format? Does the HTC Vive already support actual recording? If so, I did not realize that. In which case, I guess I'd be up for trying to make it be compatible. Arseno Dev was in, I guess, Southern Maryland, and he had a picture earlier on Twitter of something crazy happening. Let's see, where is that? Here. Yeah. Oh, that's definitely hail. That's pretty serious stuff. So, sorry, that was distracting. I should make sure there's nothing I need to... Someone actually recreating... I think that, Ben, you have a cool enough job that enough people wish that they could experience it. You could make a video, a VR experience about Ben's day at work.
He should write his own version of accounting.
Yeah, well...
Except a software dev instead of an accounting guy.
Brendan says that Ben should rewrite accounting just as software instead of accounting. So... What I'm going to do is I'm going to make it so it's possible to drop packets if you're connected. And if you do drop them, it'll be okay for a little bit. And then if you keep dropping them, it will eventually kick you out. But let's see, settings, proto buffers. I've actually never really worked with proto buffers. Protocol buffers, I'm guessing is what you mean, right? Protocol buffers, the Google thing. Someone started a collection to get that laptop fan replaced. Yeah. I'll move this.
It also needs a new battery and a CD drive.
Give me a moment here. I'm going to have to log into my router and open a port for this computer.
CD drive's been broken for years.
Why is my IP wrong? Seriously, why is my IP wrong? What is going on there? Ugh. Good, that's me. I'm gonna enable firewall, port forwards. Does anyone from the internet want to see if they can connect in? Oh, sweet. That actually works. You can ping home.cnlore.com. So you should be able to telnet to home cnlore com port 9999. No. Oh. 550. What have I done? There we go. Okay. Yay! And see if it's dying too, like it was last time for a lot of people. Because that was sad. Turn on some of the Watchmen too while we're at it. Okay, looks like this data is serving. What I think I might try to do right now is see if I can make a libsurvive front end so it can feed data without actually being hooked up, I guess.
That would be cool.
Okay. So that's right now feeding data out. Let's just edit for right now just to get things moving. Calibrate.c here. Let's see. People saying anything? Ooh, a lot of people said a lot. Okay, I can connect to homecnlr.com. It works, it works. Wait, is there Discord? Yes, there's Discord. I will...
Want me to post it?
Yeah. Oh, actually, no, I can just do it right here. Set link to never expire.
I'll post it on the YouTube.
Spectacular.
She says, now we're moving.
Okay.
Oh, I can hear myself, or you, through the phone. Okay. Bye.
Yeah, we had a power outage. Sorry that everything's back up now. Let's see if the Vive survived. Ah! That was a bad pun. Let's see. Hey, looks like everything is fine.
Cool.
I'm gonna have to go restart up the data server though.
Let's see. I was going to post the Discord.
Oh yeah. Oh, and Josh's laptop is barely a laptop anymore since it doesn't.
It also doesn't have a battery, so it turned off too.
Yeah. That was a little embarrassing. Tools. Data server 9999. Okay. That looks pretty swanky. And somebody has already connected in. 2 people have connected in. Okay. So I think what I want to do right now, just for the sake of testing things here. Ben, one thing you might have missed a little bit earlier is that I do want to change the way this works, and I think I want to do it a little bit more like what you guys were hinting at in the second or third live stream, where I find a pose estimation thing based on the camera space information from the lighthouses, and then use that to determine the location of the lighthouses and other poses. Originally, I wanted to be able to combine information from both lighthouses and then create a single pose estimation, but I don't think that will work very well. So what I'm going to try doing is switching to this other one, and it is probably more in line with what you and Alan had been talking about before with the pose estimation. Which I feel a little bit embarrassed that I'm doing things, although to be fair, what happened was I thought I was smarter and I thought I was going to do it some clever way, and then it turns out the clever way was the dumber way, and then I found out, okay, this is the better way to do it, and that you guys were right the whole time, so just, yeah. Okay, are you guys getting dropped forcibly, or are you just disconnecting? Josh, are you in chat?
They're talking about above ground cables in Europe.
Okay, so that's there. Disconnected on purpose. I got disconnected once. Still getting kicked. I guess I'll have to solve that soon.
Could that disconnection have been the power outage?
No, that would be since I started back up.
Oh. Can't fix the fan.
Calibrate client. Okay, so in here, what I should be able to do is just shove the data in through the default IMU process and through the default light process. So I kind of want to try that now.
So this would kind of be the beginning of playing back real-time recorded data.
Yeah. I don't remember how that part works. Let's find out if that actually works the way I think it does. Ooh, everybody got dropped all at once. That was weird. Maybe it's just that there's too many people connecting. Oh wait, there's somebody who's just spamming me. Oh, who's 46166? Who is that? You punk. Who are you? Somebody from the Netherlands. Who in chat's from the Netherlands and is spamming the server? Because clearly spamming. Well, whatever. You guys are having fun. I guess that's what matters. Oh, you know what? I'm gonna have to...
What's up?
In order to test... So, what I'm running into is if I try running another instance of libsurvive, so like this one's recording the data, if I try playing it back, it has to first connect to the Vive.
I can play it back.
Right,
Oh.
but it won't run for you because it can't connect to the Vive. We should probably fix that. That's definitely going to be something we have to fix sooner than later.
Why does it need to connect to the Vive?
Because libsurvive doesn't know what to do if it doesn't, and that's totally a bug. It should not have a problem with that. Libsurvive should survive without needing to connect to the Vive. Yeah, okay, I'm thinking this pluggable sources thing is mattering more and more. Isn't it really sad that before you can do anything, you find out you have to do like 10 other things, and then to do any of those other 10 other things, you gotta do like a million other things? Ugh. Somebody says check Discord. Wait, chat disconnected? I don't understand. What am I supposed to be looking at in Discord?
Maybe they're saying that's the address to connect to.
Oh, yeah. Do I have access to mute? I think I do. Timeout. So that's going to be at least a little bit... You know, whatever. Let's just try to hack it in real quick and see if we can get something that kind of works. Surviving it headless. Let's see, will that work? Data recorder. Yeah, I'm gonna have to fix those. Survive internal, right here. Yeah, we want to make it so if we are in a headless mode, we don't do anything stupid, like try to pull the USB. Hey, sweet! Okay. That was a lot easier than I thought it would be, and we didn't have to go code an entire subsystem. Okay, so what that means is this code just runs in a little spin loop all the time. So I should... What is... Uh-oh. Uh-oh. Where's tabs?
Editor.
Oh my gosh, that's awful. Why in the world would that be defaulted on? Okay, so... What is it? Get line?
Yeah.
Man, get line. What is that syntax?
Format comes first.
What? All caps, STDN? I don't remember. Uh-huh. Yes?
It's all lowercase.
Okay.
Here.
Actually, can I? Oh, you know what? I gotta get your thing up here.
It's in your master branch.
What?
It's in your master branch.
Right, but I'm saying I want to get up your
Oh yeah, I did turn that back on.
What's your IP?
Mm, 196.
Okay. There. Scanf. What's better than a how-to? Somebody else's code that shows you how they did. Do you mind watching the chat for me?
Sure.
Yeah, check that out. I can read the data.
Is that any better for the fan noise?
I can't hear it. I wonder what happens if you put it on something fabric.
It gets hotter and gets louder.
Let's put this over here again.
All right, we'll keep it like this then.
So that would be 1, 2. So. Okay, let's take a look at the first character.
You know, it might have been reverberating through the table and the mic stand.
That's definitely possible because it feels like I felt like I could feel it in my arms when you were running it that way. So let's read this data here. This is light data. Let me just try this out. Paste that in. Scanf line pointer. Is that the right number? 1, 2, 3, 4, 5.
Will this work with calibration also?
Yes, that's what I'm testing right now.
So then I can stick this in the config code into the calibrator.
Yes, that is the goal. So if this works like as I expect, I should be able to. It shouldn't be able to tell the difference. LHN time a code, or sorry, that would be timestamp a code ID when. No, it would be a code timestamp a code ID sweep len. And then up here, I think that's the right thing. Oh, this is going to be a little tricky. I think that's the right values for everything. Oh, it's headset and Watchman. Am I actually outputting? What does data recorder look like here? It goes... Oh boy, that's all out of whack. This feels totally wrong, like I'm noodling the data in the wrong place. It's just wrong that I'm like just piping the data from the serial terminal into the function call that I would normally get the data from, but I guess that makes sense.
Will that also work for your visualization interface?
Hopefully. So the first one is time code.
So the clocks are going to be different. Is that going to matter?
I don't think so, because it's going to already be processed by the host to figure out what the delta time should be. This is after it does the disambiguation step.
Okay.
So it knows like this is when in the sweep it happens. So, why am I blanking on this? My light process, sensor ID. Which one is sensor ID? That's after time code. Oh, you know what? Let's use more reasonable names. A code. Okay, is that gonna work? That is totally out of nowhere land. Wait, is that...
That's cool. It's working.
The... Is it?
Yeah.
Is that... I don't think I've ever had code like that just work. Well, let's see if he comes up with a solution, and then I'll get this committed, and you guys can go have fun with this or something. And you can tell me if it's constantly crashing on you. Oh, it died. Why did it crash? That was weird.
Huh.
Huh.
Did it make it through its...
I know why it crashed. Because it doesn't know where the points are for the headset. Because it can't connect to the headset. We should probably also store the point locations in the config file somewhere. I'm going to write that down.
The physical locations?
Yeah. Whatever, it's worth committing now. Uh-oh. Oh, Josh, how did survive config stuff? Okay, do you want to at least see if you can fire it up,
Yeah.
network-wise?
I'm bringing it, pull it down right now.
Okay, so this is my copy of Survive here.
What's your local IP?
Give me a minute.
Let me open up a new window.
When did I just use Nano?
What?
Did I just use... Somebody said seriously Nano?
Yeah, it was the Git editor. By default.
Oh, yeah, I still use that. Yeah, that's true. So I have your screen up.
Oh, okay.
By the way, everything inside this box is visible to the world.
Mm-hmm.
So I just artificially drew it. Yeah, you can go play out there and nobody can see what you're doing.
What am I doing? I've forgotten.
You're going to be
Netcat.
pulling, and then... Oh, yeah, Netcat. Oh, I'll give you my IP.
Actually, I can move that in here.
I don't know what my IP... Oh, yeah, I'm 192.168.11.254. But I don't know why I don't know my IP. I don't know what's up with that. 9999. There. Sweet. Look at that data.
There it goes. All right. So what am I starting? Calibrate client?
Yeah, calibrate client. You have to pipe the data into calibrate client, though, from... Yeah. Calibrate _ client. Check that out.
Cool.
You know, I'm going to go...
I do not have the Vive connected to my machine.
Yeah.
This is being done over the network.
Let's see here. Does this? Yeah, you can see it in real time. Oh my gosh, it's really. I
It's-
know you guys can't see it, but it's pretty low latency. Huh. Yeah, it's. So that totally is not what I would have expected to have just worked, but. But that is interesting. That does give us another reason to store the point locations of sensors in the config files. That's going to be a pain.
Yeah.
Yeah, because as soon as it gets to the final calibration step, it's like, I need to know where the points are, and then it just crashes. No, although, side note, I do have a bit of an ESP32 project I've been playing with. Let's see if I can show that. Workspace 3. Wait, why didn't that work? Is this camera? Oh, camera got messed up. That's my parents calling, probably about dinner. Hey, I'm actually doing a live stream right now. Can I call you back in, I'm guessing, an hour? This is going to be probably a short live stream. Josh, are you up for...
Should we?
I mean, I'd like to go out with
Okay.
my parents and you, and
All right.
you're up for it?
Yeah.
Okay, he says he's up for it. Yeah, 2 hours would be... yeah, we'd definitely
That's plenty of time.
Yeah, we'd be plenty done by then. Bye. Let's see here. UVC... Wow, my camera's just hosed. Let's try reseating it. Hey, there we go. Okay. So I have actually been playing with the ESP32 as, why is it not focusing? Come on. Oh, whatever. Point is, I've been playing with the ESP32, and it's been working out pretty neat so far, just little things here and there. And I totally am now able to print circuit boards at home down to 0.4 millimeter BSC, so that's kind of fun. Oh, another thing that we did with the HTC Vive stuff. Oops. So before, there was this thing where we were completely tied to the 48 megahertz that the Vive itself used. But the problem is that there's really no good source for 48 megahertz on the ESP. So for collecting just regular data, that was not going to fly. So libsurvive does now actually have configurable time bases. So this has to do with the disambiguator, but the idea is that all of these would be prorated to whatever speed you actually want to operate at. I'm an idiot. I just realized it has... what's going on? Oh. There
Somebody
we go.
wants to know, what cheap printer do you recommend?
Cheap printer
Slickmoto.
for what?
Slickmoto was asking.
For PCB printing?
Yes.
For PCB printing, right now I use a Phantom P2502W. They are super cheap. I will pull up and I will show you guys just how ridiculously cheap. Is my internet not working now? This is just great. But I'm streaming though, right?
Yes.
Yeah,
Well,
I think it's...
No. I don't know.
Am I streaming now?
Okay, there we go. I think the internet here dropped out,
Oh, okay.
but it's going now.
No, I'm definitely here, still here. We didn't have a power outage. I don't know what that was. It's this printer right here. When I bought it, it was $36.99 or $37.99 new, and came with a pretty decent sized cartridge. And I bought another cartridge for it. They're really cheap. They're really nice. They're plenty fine for PCB printing. Normally, I have to double up though because it doesn't output enough toner, so I have to like double up the transparencies, stack them, but other than that, it's fine. Other thing is, I now switched out my LED process, or my process for exposure, to an LED, which I thought was going to slow me down, but it turns out it exposes in about 4 seconds, so that's not an issue anymore. I don't even know what to do now.
Somebody asked what part of this project runs on the ESP.
So goal is right now, for the most part, libsurvive, we're just going to be working on getting... I really want to do ESP tags to begin with. And then after that, I can go switch off to whatever. But I do want to do... I want to try to get libsurvive running on an ESP32 so that I can create kind of an AR environment where it'll be like a little screen that you can hold up and like look through and see around, and be able to do that very, very inexpensively. I think there's some really neat things you could do with that. But the first part of all of that has to do with sensing on the ESP, which I think I'm going to do with the ESP8285 and be able to do it that way. But that does not directly involve libsurvive. But I still want libsurvive to be super duper Dune Buggy-esque, like super stripped down. So I think that would be fun. I don't know. I don't really have anything else to go over right now. We got some data running. We can kind of process it. Yeah. Yeah, 4 seconds. 4 seconds. I think I should probably have a video of that just because it looks so ridiculous. It's just like, bzzz, done. Okay, I don't know, I don't really, I mean, I feel like the only work I'm going to be doing is to do some of the more pluggable stuff, with the Vive, and I'd really rather not do that on Livestream. I think that would, detract from it. Yeah, actually, so I should have clarified that. With the ESPs on the, on what I want to do with them, is it's going to be using the raw packets from the ESP. So you don't have to have all of this overhead associated with connecting up and staying connected. Instead, it'll just transmit a raw frame whenever it sees a light pulse and immediately just send it. And then on the computer end, it'll have at least 2 probably Realtechs just sitting in passive mode listening. And whenever a message comes in from an ESP, it just goes and processes it right then and there. That way you don't have to worry about staying connected. You don't have to worry about the added latency of a wireless network and stuff like that. It's extremely low latency when you use the raw packets. So that works out pretty well. I don't really have anything else. Do you?
No, I'm just looking at code right now.
Okay. Yeah. ESP32, well, 3.5 is kind of hard to get without spending a mountain on shipping. But yeah, the ESP32 is a lot more able, you can get it a lot more easily. You can also just buy the ESP32 raw chip from me. I have 5 of them for $14.99. So, yep. So I guess unless there's anything else, based on what we had said we were going to do earlier on in the stream, probably just going to go call it quits. Thanks everybody for coming out. Had a little bit of fun here going over the different things. It's a little bit difficult to get work done right now with any one phase of it, but I don't have a color laser printer. No, that's
Nope.
Josh Allen. Yeah. Well, thanks for everybody for coming out. I'm glad this could be a real quick thing. Well, we still haven't gotten the RGBY LEDs. I still can't get the guy to sell them to me. It's sometimes getting things from people in China is a lot more difficult than you'd expect. Okay, yes. Bye, everybody.